Time travel has always fascinated humanity. From ancient myths about prophets who could see the future to modern science fiction stories about machines that bend space and time, the idea of moving across timelines has never left our imagination. But what if time travel were not just a story? What if advanced civilizations, human or otherwise, were able to send signals backward through time? Could we, here in the present, detect such transmissions from the future? And if so, how would we even recognize them? To begin answering this question, we must first look at what physics says about time. Albert Einstein's theory of relativity revolutionized our understanding. According to relativity, time is not a fixed universal clock. Instead, it flows differently depending on gravity and speed. Astronauts on the International Space Station, for example, age slightly slower than people on Earth because of both their speed and weaker gravity. This is called time dilation, and though small, it proves that time is flexible. From there, the idea of moving into the future is relatively easy. If you travel close to the speed of light, time for you slows dramatically compared to those you leave behind. This is not science fiction. It is a confirmed effect. The challenge, of course, is building technology that could achieve such speeds. But the harder question is going the other way, into the past. Most physicists agree that traveling backward in time is filled with paradoxes. The grandfather paradox, for example, asks what happens if you travel back in time and prevent your own existence. Yet some theories suggest that time travel might be possible if the universe allows closed time-like curves, paths in space-time that loop back on themselves, like tunnels connecting two different eras. Wormholes, hypothetical bridges through space and time, are sometimes discussed as one possible mechanism. If civilizations in the far future ever mastered these concepts, signals might be easier to send back in time than physical travelers. Instead of spaceships appearing in ancient Rome or medieval Europe, we might expect subtle anomalies, strange data, unexplained signals, or information that appears too advanced for its time. This brings us to a fascinating thought. What if some of the mysterious signals we have already detected are not from distant civilizations in space, but from our own descendants reaching back across centuries? Let's consider some real mysteries. The WOW signal of 1977, detected by the Big Ear radio telescope in Ohio, remains unexplained. It was a strong, narrow-band radio burst lasting 72 seconds, perfectly fitting the profile of an artificial signal, yet it never repeated. Some astronomers speculate it was natural, others think it was extraterrestrial. But if time-traveling civilizations exist, could it have been a message from the future, aimed specifically at us during that year, before disappearing again? Another intriguing idea is the phenomenon of fast radio bursts, or FRBs. These are powerful, millisecond-long bursts of radio waves detected from space. Some repeat, many do not. The energy involved is enormous, sometimes more than our sun produces in days. Scientists propose explanations ranging from collapsing stars to magnetars. But a small minority of researchers have asked, what if some FRBs are engineered signals, perhaps even carrying information we don't yet understand? If a future human civilization wanted to send signals back, using the universe's own physical quirks might be their method. History itself sometimes feels like it carries anomalies. Ancient myths describe sky gods, descending with knowledge of astronomy, mathematics, and architecture. Civilizations such as the Sumerians or the builders of the Egyptian pyramids showed remarkable leaps in knowledge. Of course, historians and archaeologists explain these achievements through human ingenuity. But the speculative question remains. Could some of these myths be cultural memories of contact, not with extraterrestrials, but with future humans sending information backward? The idea is not mainstream science, but it fascinates those who study both ancient history and theoretical physics. One of the biggest arguments against receiving signals from the future is causality. Physics is built on cause and effect, an event in the present leading to a result in the future. If signals from the future influence the past, wouldn't that create paradoxes? Here, modern physics offers potential loopholes. The many-worlds interpretation of quantum mechanics suggests that each paradox could create a branching timeline. In this view, if a signal from the future changes the past, it does not rewrite history. It creates a new timeline where that event is true. Our own timeline would remain untouched, but a parallel one would emerge. Thus, signals from the future might not be paradoxical. They might simply shift reality into multiple versions. This theory connects intriguingly with the Fermi paradox, the question of why we do not see evidence of other civilizations despite the high probability they exist. Some scientists speculate that civilizations that master time may no longer spread through space in the way we expect. Instead of building colonies among the stars, they may choose to engineer reality itself, traveling across eras rather than distances. If that were true, then looking for signals from the future might be just as important as looking for signals from distant galaxies. But how could we actually detect such signals? One idea is to examine anomalies in existing data. Radio telescopes have decades of archived recordings. Machine learning could comb through this data to find patterns we previously missed. Bursts that look artificial, but were dismissed as interference. Another idea is to deliberately broadcast messages aimed not at other stars, but at ourselves in the future. Imagine sending a coded signal into space with instructions for future humans to reflect it back in a specific way. If one day the signal returned, not from light years away, but from decades ahead, it would be proof of time communication. There is precedent for retrocausality in physics experiments. Some interpretations of quantum mechanics suggest that choices made in the present can influence events in the past at the quantum scale. While this is far from proven, it raises the possibility that time is not strictly one-directional. The famous delayed choice quantum eraser experiment, for example, seems to suggest that particles can decide their behavior based on measurements taken after they have already passed through a detector. If nature itself allows such effects, advanced civilizations might exploit them on a grander scale. The cultural impact of detecting a time signal would be staggering. Imagine scientists announcing that a radio burst carried structured information and, after decoding, it was revealed to be instructions, warnings, or knowledge far beyond our current science. Humanity would face a dilemma. Do we follow the advice of our descendants, even if it changes the path of history? Would governments hide such discoveries, fearing chaos? Or would this unite humanity, knowing that our future selves cared enough to reach back? There are also ethical questions. Should we even attempt to send messages to the future? Could this create paradoxes we cannot predict? What if only certain groups received the information, giving them unfair advantage? History shows that even small technological leaps, like gunpowder or nuclear weapons, can radically alter civilizations. If we received knowledge from the future, would we be wise enough to use it responsibly? Science fiction has long explored these dilemmas. Stories like Interstellar imagine humans manipulating time to save themselves. The TV series Dark presents time loops where every action is tied to the past and future. Philosophers ask whether time is truly linear, or if all moments exist simultaneously, like pages in a book, with consciousness flipping from one to the next. If so, then communication across time might be less impossible than we think. Still, most scientists remain cautious. Extraordinary claims require extraordinary evidence. So far, every signal we have detected has natural explanations, even if mysterious. Magnetars, quasars, and atmospheric interference account for much of what once seemed alien. Skepticism is essential in science, yet the question persists because time travel touches not just on physics, but on human imagination. It reminds us of our desire to reach beyond limitations, of space, of time, of mortality itself. When thinking about signals from the future, we must also consider how humanity has historically dealt with predictions and prophecies. Across cultures, there are countless stories of individuals who seem to know what was coming. The Oracle of Delphi in ancient Greece delivered cryptic messages that leaders often interpreted as glimpses of the future. Medieval Europe had astrologers who believed the stars could reveal events centuries ahead. In indigenous traditions, shamans sometimes spoke of visions where ancestors revealed what was to come. While these may not be scientific examples, they demonstrate a deep psychological connection humans have with the idea that information can cross time. If future signals ever were real, they might first be mistaken for mystical experiences, only later understood in scientific terms. Another relevant thread comes from mathematics and information theory. Claude Shannon, the father of modern communication, emphasized that all communication is about encoding and decoding signals within noise. If a civilization in the future wanted to contact us, they would face the same challenge. How to encode information so that a less advanced version of humanity could understand it. Prime numbers, binary codes, and geometric sequences might be the easiest. A sudden appearance of such patterns in cosmic noise would be suspicious. We already use similar logic in SETI, scanning for narrowband signals that nature rarely produces. If a burst carried unmistakable mathematical order, it could raise the question, is this from aliens across the galaxy, or from humans across time? Let's also explore the idea of self-consistency. Some physicists, such as Igor Novikov, propose the Novikov self-consistency principle. It suggests that even if time travel is possible, events must remain consistent. Any action taken by a traveler or a signal sent to the past would always be part of history. In this view, paradoxes cannot occur because the timeline is fixed. For example, if we received a signal tomorrow with instructions to build a certain technology, it might be because our future selves knew we would always receive it, and history unfolds accordingly. This theory paints time not as a fragile thread, but as a robust loop, immune to paradoxes. If true, we might already be living inside a universe shaped by signals from the future, without even realizing it. Another fascinating angle is the possibility of closed, time-like curves in astrophysics. The rotation of extremely massive objects, such as black holes, can theoretically twist space-time in such a way that paths loop back on themselves. If advanced civilizations can harness or manipulate such regions, they might send data streams back through these loops. Our telescopes, in turn, might one day detect signals that appear to come from nowhere, not from another star system, but from another epoch. Such discoveries would be revolutionary, forcing physics to expand into domains we currently only dream about. Cultural consequences deserve even deeper thought. Imagine what it would mean for religions worldwide if signals from the future were confirmed. Faith traditions that already incorporate prophecy might see it as validation, interpreting the signals as part of divine design. Secular communities might embrace it as evidence that humanity endures far into the future, a comforting thought in an age of existential threats like climate change and nuclear risk. Conversely, some groups might reject the idea, fearing manipulation or loss of free will. The debate over whether history is predetermined or open could intensify. A single decoded signal might spark global movements, philosophical revolutions, or even political conflicts. Finally, we cannot ignore the human longing behind this speculation. Our search for extraterrestrial life, our fascination with time travel, and our myths of prophecy all reveal the same desire: to know that we are connected to something larger than ourselves. Signals from the future would represent the ultimate connection, not just to others, but to our own destiny. If our descendants could reach back, it would mean humanity not only survives but thrives long enough to master time itself. Such a realization could inspire hope across the globe, reminding us that despite today's challenges, our story is far from over. Perhaps, one day, our scientists will uncover evidence hidden in plain sight, a pattern in cosmic radiation, a message in archived radio data, or a sequence of pulses that could not have come from any known source. At first, it might cause skepticism, even ridicule. But as analysis deepens, the possibility would grow harder to dismiss. And then the world would face the most profound moment in history, confirmation that humanity has a future and that future has already touched us. And if that day comes, the first true message from the future may not be a grand revelation of technology or prophecy. It might simply say, "We made it. Keep going."